All right, so we are in the last throes here of our class. I have a final exam prep written for you guys. Well, not quite. It's getting there. I will post this as soon as I can. I've got like one problem really left here. Well, I've got right 6, 7, or 7, 8, 9, 10, 11, and 12 to kind of sort through. But that's how you're going to see that partially. Okay. Partial fraction problem. I was typing out hyperbola and my mouse jumped. Okay. So, but I will post this as you see it. So problem number one is going to be an average rate of change. Problem number one and problem number two, I'm not picking all of these. I'm picking one of them. So I'm probably combine problem one and problem two into like a part, problem one with an A and a B part. So there may be, another additional problem here. So I'll see if I can't add that. But one of the biggest things they're going to ask you to do in Calc 1, okay, so like the next thing you're going to have to do is figure out like average rates of change, okay, or difference quotients. And I really want you to know what they mean and how to calculate them. And these are all the different types that you're going to see. Actually, there's more types. Okay, if you take in trig, right, you have 6 more functions that you get to deal with. But and we didn't do logarithms, we didn't do exponents with this. But these are your basic types. Okay, we could start to mix and match them a little bit, but for a final exam, these are the 4. Okay, so why don't we go through these 4 and maybe number 2, and then we'll see what we have. Okay. So I want to kind of keep it to not like an hour long because we don't, got a lot. We have a bit of time left in this semester. It doesn't feel like it, but we really do. So we're given 1 over, and we have an x minus 3, right? And they want to know what's the average rate of change. Okay, and I'm going to write the problem like exactly like this. So if you think I have to memorize this formula, no, I'm going to give it to you. It's going to look like just like this. Find the average rate of change, comma, this thing for the function I'm going to choose. Okay. So we're going to get f of x plus h minus f of x all divided by h. Okay. And what this means to do, take 1 over h, right, this is the same thing. When you start to get like fractions, I found it to be very helpful on the amount of paper I was using for my homework to move this off to the side. So that's what I learned how to do as a student, rather than use up 4 lines every time I'm doing a problem. So what we're going to do here is we're going to say this is 1 over h, okay, and we have 1 over x plus h minus 3 minus 1 over x minus 3. Okay, now this is pretty much one of the more straightforward ones. Okay, there's only one real tricky one, which is the square root function. But this one, we've got 2 fractions and we got to subtract them. How do you subtract 2 fractions? Right? How would I do this? How would I do 1/12 minus 1/13? How would you do that? Right? You would find a common denominator, wouldn't you? Guess what we're going to do? We're going to find a common denominator here. So we're going to have 1 over h. Okay, we have 1 over, this is x plus h minus 3 times x minus 3 over x minus 3 minus 1 over x minus 3, and this is x minus x plus h minus 3, x plus h minus 3. Okay, now here's one of those things about this kind of problem. You do not multiply out this denominator, okay? Notice I didn't even do it with this one, right? This is just 13 minus 12 over 13 times 12. So this is 1 over 13 times 12. And when I get around to it, I'll multiply out 13 times 12 and get like something like, what, 130? No. It's got to be bigger than that. So it's got to be bigger than 144. So 156, I think. All right. But I'm not going to get around to multiplying that out until the very end. I don't want you to multiply this out, okay? The first thing we're going to ask you to do after it's done is tell me where the asymptotes are, which means you're going to have, right, you're going to have a factored form. So don't multiply this out unless they insist of multiplying this out. And I'm specifically telling you, don't do it. Okay. It's not that you get in trouble for not doing it, okay? And it's not wrong. It's just like you've got better things to do with your time. Oops, that's a minus. Okay, minus. Oops, is x plus h minus 3 here? All right. And x minus 3. There we go. So now that we have common denominators, we can make one fraction. So this is 1 over h. And we've got x minus 3. And what I'm going to do is I'm going to distribute this negative sign into this. So we're going to say this is negative x minus h plus 3. Okay, that's this negative sign visiting each one of those terms. Okay, x plus h minus 3, x minus 3. And now we're going to combine some terms, right? We have a couple of x's. They're both, they're both going to cancel. Right, we have a plus 3, we have a minus 3. Right, I said that in the wrong order, but still. So here we go. We have a negative h over x plus h minus 3, x minus 3. We have a 1 over h out in front too, don't we? And these are going to cancel now. So when we're done, we're going to get negative 8, or negative 1 rather, not negative h, negative 1, all right? Negative 1 over x plus h minus 3 and x minus 3. And I know it doesn't look like an answer, but that is the answer. And at that point, you are done. Okay, I'm going to jump into 2a here. Okay, it says, hey, refer to the previous problem for the functions. For each part, calculate the average rate of change for the given x and the h. Also, use the alternative formula, f of b minus f of a divided by b minus a, right? Difference of y divided by difference of x, slope, okay, for a given ab for each pair. Finally, comment. You should be able to note whether or not the values are the same or different, and make a conjecture as to why they are the same or different for each part. And if the reason is the same for all 4 cases, you don't need to repeat yourself. If you get the right answer for one of them, I'm just going to assume it applies to all of them. Okay, so, and by the way, I'm picking one of A, B, C, and D, and the corresponding A, B, C, and D for your final exam. You're not getting 4-part questions, each requiring 2 pages worth of work. Okay, that is not how this is going to play. All right, it's fair to pick one. It's not fair to pick them all. Okay, so what do we have here? We have x is 5, h is 1. So we have x is equal to 5, h is equal to 1. And then we want to do f of b minus f of a over b minus a. And what do we have here? We have 5 and 6. We have 5 and 6. B is equal to 6. Okay, let's see what happens. Okay, so here we go. We have negative 1 over, and we're going to have 5 plus 1 minus 3 times 5 minus 3. Let's see what that comes out to be, right? This is minus 1. We have 5 plus 1, which is 6. 6 minus 3, that's 3. 5 minus 3, that's 2. So this will be 1 over 6. Okay. Now, let's check this out. We have to go back to the original function, right? That was 1 over x minus 3. We want to do f of b minus f of a divided by b minus a. So here we go. Okay, I'll do the hard part. Okay, not really. But this was 1 over 6 minus 3 minus 1 over 5 minus 3, yeah? Well, this is 1 over 6 minus 3 is 3, right? Minus 1 over 5 minus 3, that's 2. And this is all divided by 1, right? I don't need to write that anymore. Okay, so we get 1/3 minus 1/2. Hey, we should get some common denominators here, right? And we get 2 over 6 minus 3 over 6, which is minus 1 over 6. Hey, would you look at that? They match. Of course they do. Okay, so they're supposed to match. And I don't have like the best way of saying this. I usually say comment on your answer. And a lot of times students will look at that and it's like, they're the same. Like, that's incredibly insightful. That's not really what I was expecting on the end of a pre-calc exam. Okay. What I really want you to do is say something like f of b minus f of a over b minus y is an equivalent expression to f of x plus h minus f of x divided by h, okay? Because really what we did is we took our a and we replaced it with x plus h, right? We said x here, b was x plus h. So really what you have is x plus h minus x is equal to h. That's how we got that h, okay? Or these both represent this, you know, these values both represent the slope of the secant line between the points five and 5 plus 1, which is 6. Okay, that's all well, that's pretty much what I'm looking for, is just for your acknowledgement that this thing and this thing are the same expression. They're just different ways of saying it. Usually we use this way if you've got numbers, and we use this way if you got letters. Okay, that's really all we're looking for here. Okay. So be careful about doing that. By the way, if you come up with an answer, like at the end, your answer is 1, you've done something terribly and tragically wrong. Okay, if this is your answer, then you've done something terribly wrong, because what we're looking for, right, is the slope of the secant line, and what you're saying to me is that this function always has a slope of 1, and there's only one family of functions that have a slope of 1, and that would be y is equal to 1x, and then honestly plus b, because any, regardless of which one you pick, right, they all have a slope of 1. But 1 over x minus 3 does not look like this. That's not the same function. So if you end up with a 1, you are tragically wrong. Okay, in a way that I only grade out of 6 points. If you tell me 1, I'm always tempted to take off 7. Okay, I haven't done it, but it's one of those things where it's like, really? One of my colleagues, if you give her that answer, if you can't do that one, she's not grading the rest of your final. You're done at that point, and you're gonna have to repeat. Okay, so and same thing. I mean, I've had university teachers at my teaching calculus that have asked a question like this. They're like, you can't solve this. You're done. We're not even grading the rest of your final. I don't care how much other calculus you know. You don't know enough. Okay, no matter what, you don't know enough. So be real careful with this problem. Like this is one that, like, if you say, hey, I finished pre-calculus, you should be able to answer this question. Okay. Okay. What about the next one? All right. We might save some of these until tomorrow, but okay. Here's the other tricky one. Okay, is square root of x minus 5. So here we have g of x is equal to square root x minus 5. All right, and I would like to know, what's the difference quotient? So this is g of x plus h minus g of x all divided by h. Okay, so let's see what that looks like. So that is the square root x plus h minus 5 minus the square root of x minus 5 divided by h. Okay, so we kind of have to get rid of the square roots, right? Because the idea is we want to cancel this h. Okay, preferably with something, but we want to cancel that h. That's the goal. You can't square root this, okay? Because this format right here, g of x plus h minus g of x over h, this is an expression. I mean, there's only an equal sign because I typed in this stuff. There's no really a both sides of an equation here. Okay, this is an expression. There's not really an equal sign versus an equation where you're solving for something and there is an equal sign. Okay, so expression, not the same as equation. If I square this, I got to square the other side. There really isn't another side. So I can't just go around squaring things. My bank account would look really, really bad if I did that. So wait a minute, how would it look bad? like because numbers that are less than 1, if you square them, like go ahead, square a half, you get a quarter. Okay, so numbers that are less than 1, if you square them, they get smaller. Okay, that's the joke. All right, x plus 5 minus 5. So how do we get rid of the square root? Well, there's something called a conjugate. So we're going to multiply by 1. And the one we're going to look at looks like this. Right, that's 1, sort of. Actually, it is, because it's the same thing. Top and bottom, same thing. Just multiplying by 1. You can multiply by 1. That's not going to change an expression. Multiply by 1. By the way, if you're ever like, what are the tricks in math? Multiplying by 1 and adding 0. Those are our 2 tricks. Okay. Just like in accounting. So, oh, I shouldn't have said that. I feel dirty now. Okay, I'm joking. If you guys want to be accountants, it's a good career. Okay. Okay. And we're going to multiply this by x plus h minus 5 plus root x minus 5 equals, okay? So we're just going to FOIL this, okay? Again, we're going to multiply out the bottom here? Absolutely not. Okay, like I said, it's not wrong to do it. It's just that I think you have better things to do. You don't need to be doing this. That's a minus. Sorry about that. It's a minus 5. Okay. So times. Multiplying the square root by the same square root, we just end up with the value here. This is x plus h minus 5. Okay. Notice what's going to happen here with these cross terms. Okay. Notice what's happening with my cross terms here. We have a plus square root of x minus 5 times square root of x plus 5 minus h, or minus x plus h minus 5 rather. We have a minus square root of x minus 5 times square root of x plus h minus 5. So this term and this term, those are the same. They're going to cancel out because one of them is plus and one of them is minus. Okay. I'm not going to write that one down because they're going to cancel. Okay. And then we have minus, and then these two terms multiply by each other. But there's a minus and a plus, so it's going to stay minus. And we end up with the same square roots, so that's going to be x minus 5. All divided by this mess down here. What about these square roots? Like, you got to take a sacrifice somewhere. Okay. Right now, we decided to sacrifice the denominator to see if the numerator can give us something, but you know, one of these has to be a sacrifice. So right now we're sacrificing the bottom looking nice. All right, there's some stuff that cancels here, isn't there? Okay, we have an x, we have a minus x, we have a minus 5, we have a plus 5, right? Don't forget to distribute. So what do we have at the end here? We have an h. Okay, we have an h. We have a square root, x plus h minus 5 plus square root of x minus 5. Okay, and then now these two cancels. What was the goal? The goal was to cancel this h. So now we're good. Our answer is going to look like, okay, 1 over square root x plus h minus 5 plus square root of x minus 5. See? Delightful. We still have an h in our equation, right? Because what does x minus 5 look like? I have to tell you a starting point and an ending point for you to get, right, to get a slope. These are going to be different slopes. If I ask you this slope versus that slope, they're going to be different. Okay, so that h has to be there. Okay, great. Let's go on to part B here. Okay, so this is x is 6, h is 3. And then what do we have here? We have a is 6, b is 9. if you guys have noticed, like B seems like to be x plus h. Like it is exactly x plus h is the 9. Okay, that is exactly what's going on. So let's go ahead and type in the numbers for this one. So this is going to be 1 over square root of x is 6, h is 3 minus 5 plus, right? And then we have x is 6 minus 5, right? And now we are compare to, right, f of b. So we're going to say b is 9 minus 5 minus the square root of a minus 5, 6 minus 5, all over, right, 9 minus 6. Okay. So what do we have here? I hope I wrote this one down right. Okay, so this is 1 over, okay, this was f of b minus f of a all over b minus a. That's what this is. So this is 1 over 6 plus 3 is 9. We have the square root of 9 minus 5, the square root of 4, plus the square root of 1. This should be a third, right? Square root of 4 is 2, square root of 1 is 1. So what do you have up top here? Well, 9 minus 5, right? That's 4, square root of 4, minus the square root of 1, all over 6 minus 9 minus 6, 3. 2 minus 1 over 3, which is a third. Hey, look at that. They turned out to be exactly the same. Okay. And they should, by the way. So this is a way for you to check to see whether you're going to get the right answer or not. Don't make a shortcut out of it. Right? Go through it the way that I just did by doing, because I really want to see you go through this. Okay, because in calculus you're not going to get like necessarily 2 points to compare them to. So I need to see this mechanic. That's what this question is asking. The next one is saying, do you understand the geometric significance? What's going on here? And can you explain what's happening? Yeah, these are both the slope of the secant line between 6 and 6 plus 3 being 9. Okay, so that we can do that. All right, let's pick one more. Let's pick number 4, and then I'll come back to number 3. Okay, so this will be problems 1A, 1B, and 4. Okay, so determine the exact solution, right? So this is another one of those canonical problems. Like you say, oh, you passed pre-calculus. You should be able to solve a problem like this. Actually, college algebra, you should be able to solve a problem like this. Okay. All right. So we have exponents, right? We have variables, rather we have variables in the exponent position. What should we do about that? Oh, we got to take a logarithm to get them down. Doesn't matter which logarithm you take. No, I would choose either ln, right, because we have an ln button, or an log button. So either choose log or choose ln. I'll choose log in this case just because I know what's coming and we're going to have an ln later. So take logs of both sides. All right, this guy comes down in front, this guy comes down in front. Very good. 1 plus 3x parentheses L log 11 is equal to, what is this, 5x minus 2. Go away. Okay, parentheses log 12. Okay. Now it says we have to have exact answers, but like I said, when we went over this a long time ago, if you go into log 12 and you type this out in your computer and you say, okay, well, what's log 12? I need to know. Okay, and you type that number in instead, I will dock you a point, right? You're going to go from a 6 to a 5 or 5 to a 4 or whatever. But if you don't get anything else wrong, that's a 5 out of 6. Take the 5 out of 6. All right. Don't take 0. Take 5. All right. Get as much points as you can with this. Alternatively, I'd love for you to do like the grown-up way. I don't really want to say it that way, but yeah, the more advanced method, and just leave it with the logarithms. So here we have log 11 plus 3x log 11, that's equal to 5x log 12 minus 2 log 12. Okay, I'm going to put this one over here. I'm going to put that one over there. Okay, so we're going to subtract 3x log 11 from both sides. Okay, I'm going to add 2 log 12 to both sides. You can't add these, right? I mean, all you could do is show and say, great, I've got log 11 plus 2 log 12. Okay, you got a British pound and 2 euros. You don't have a bank. How much money do you have? You got a British pound and 2 euros. Okay, that's it. There's no exchanging. You just have 2 sets of coins. All right. And that is all equal to, and then we have a 5x plus a minus 3x. Okay, so 5x log 12 minus 3x log 11. Notice, right, that x, right, is common to both of these terms. We're going to factor out that x. So here we go. We have x. We have 5 log 12 minus 3 log 11. That is equal log 11 plus 2 log 12. Right? And then the last thing, divide. So x is equal to log 11 plus 2 log 12 divided by 5 log 12 minus 3 log 11. Okay, and you're set. That's it. It's the end of the line. Okay, so it's take logarithms of both sides, move the exponent down, shuffle, factor the variable out, divide, done. Okay, so that's, I'm going to go ahead and stop it here. That way it'll be a shorter video, and I will continue going forward. I will also post this thing to your class, and I'll probably do it earlier rather than later, so I'll come up with a better plan for these guys. Okay, so we'll stop there, and we will see you tomorrow. Okay, good luck, and see you.